Hi, this is Chad from Reichhardt, back again to walk through the Reichhardt PSR guidance system main menu and all the main settings of our system. From the main screen or the home screen of the Reichhardt system, you'll want to press and hold the wrench button. And after about 2 seconds, it'll navigate you to the main menu. And from here, you'll have access to several different menus for setting up our system as well as diagnosing issues. First icon, Teach In, letter A, is for general setup of the system as well as configuration of some of the inputs and outputs. Letter B is for our user interface, choosing a screen, choosing our language settings, and other display settings like stretching or scaling the user interface. The next icon over, GPS, is, as you probably guessed, is for configuring our GPS input, baud rate, message format, as well as outputting GPS and warning levels with GPS. Icon D has icon says GSM. This is for a Reichhardt sourced RTK modem for configuring and troubleshooting. Letter E, Diagnostics. This is a very common menu for troubleshooting, and that is all our inputs and outputs and just general system information to allow you to troubleshoot if there are any issues with our system. Icon letter F, it's got the blue circle with an I. That's for our service partner, showing service information. Icon letter G is a working calculator as just an additional resource or tool. And then icon H is where you would enter in a PIN code for additional access for additional menus, typically for installers or technicians. So the first menu has an icon letter A in the top right hand corner. It says Teach In for the icon. When you click on that icon, it takes you to our Teach menu. And from here we have some settings regarding the setup of our system. First icon you see available here is the tractor icon. If I click on that, we have our vehicle code. And this is where an installer or a technician would put in a code to configure our system for first time use for a specific machine. So for example, this is a vehicle code for a generic tractor. We may have a code for a specific brand tractor or a specific brand combine, and for those, each system or each install will have a unique vehicle code, and those are noted in the respective installation manuals. And we'll probably do a separate video walking through this process, but for today I just wanted to show you what the icon and what the menu is for. The next icon over in the Teach menu has an icon letter F. You see a kind of an icon that shows a V. I think that stands for velocity, and it's supposed to represent our speed input configuration. So if I click on this icon, it'll take us to our Teach Speed sensor, and here we can pick a different speed source. And I'll just show you here. You can click and you can see all these different inputs. I'm not going to go through the details of this. That'll be saved for a different video talking about the setup of the system, but just to note that is available even to the operator level. So the system's currently not unlocked and it is accessible. The next icon over has a letter G, and it has an icon with orange arrows wrapped down off the roof. When I click on that, you have the Teach Terrain sensor. And this is where we go in to set up and calibrate a tilt sensor or the embedded 6-axis terrain comp on a Reichhardt MC controller. And there's a few different input settings here. We're not going to go into detail in this video, but again, there's additional adjustment for calibrations if the controller's ever moved. Next icon over looks like a joystick. If I click on this, letter L, you have Teach Joystick. And with the PSR system, you can either have no joystick. A lot of our implement guidance systems will use what's called a PSR joystick. It's a direct wire joystick where we can calibrate it and use this for different functions with our system, as well as we can set up and use an aux joystick. We're going to go ahead and leave this off for now. And then the last icon over, letter M, looks like a picture of a gear. If I click on that, I have Teach Basic Settings, and we can go in and adjust some different values. So one thing that's new in the newest software, if you have current release software, this is actually in a different area, but your nudge increment is now in the Teach Basic Settings, and this is where you would adjust how many button or how many inches or how many centimeters left or right of the line will you nudge the system with a single button press. Above here we have a setting that says ISO maintain power, and from here we can select off, on, or a period of time, and that will send the maintain power message for a period of X time whenever we see that message from the tractor that we're hooked up to. And the idea of that is giving our controller and or a connected display enough time to properly shut down. The checkbox here in the middle where it says Enable External Navigation would be utilized if you're using a Reichhardt sourced display for integrated functions like mapping and integrated steering, similar to the track leader top of the old Mueller comfort terminals, things like that. We have other terminals currently that would also support it, but that would be what that button is for. So those are your basic teach menus. These are the ones that are available to you without any kind of pin menu or access code entered. If you enter an access code as a technician, you may have additional icons, as well as these icons may vary based on your machine profile. After walking through all the teach menus, you need to press the escape button. It'll take you back to the main menu, and we'll proceed to walk through the rest of the main menu settings from here. The next icon over, letter B, has a picture of a screen that says ISO on the front. It is for configuring the user interface and the general layout of the system. So first thing you'll see here is use VT settings, and we have a checkbox. I can choose to select this. These boxes will gray out, and then it will use the regional or the regional settings, I think is what it's called. Let me take a look here. It'll use the localization settings. So if I go into a display, I can pick units. Right now, all metric, decimal, etc., etc. And some of this can be then picked up by our system and updated in real time. Or if you want to override everything, you just uncheck this box and you choose your preferred language, preferred units, and whether you want to use a period or a comma for your numbers. So for example, I'll switch to German, save it. We actually get a new pool to load up real quick, or a new home screen I should say. And now we're in German. Different text altogether. I'm going to go ahead and change that back to English so I don't get too lost. Also in the terminal configuration menu, we can adjust our data scaling. So right now we have centered. We have an option where you can pick full. So you can see right now with our screen we have a bit of a gray banner around here. Our native resolution of our system is 200 pixels by 200 pixels. And then we can scale that out by a whole number. So for example, I can have a 200 by 200 or a 400 by 400 or a 600 by 600 layout. That way we're not stretching anything. The typical UT, most UTs out there run a 480 by 480. So we're running 400, 400, so we technically have 80 pixels here total across our banner that are unused space. We can stretch to a full screen layout, and when I do this, it'll stretch all your pixels. It'll also stretch out the soft key layout. Depending on the display, it may look a little bit funny, but we'll go ahead and try it. I'll hit the OK button. So now you can see the full screen layout. Now we have no space in here, and it actually looks pretty nice in the case of this UT that I'm running on my laptop. Some UTs though, it creates a lot of sharp jagged edges and kind of some funny looking icons, but if we want, we can just leave it at the full screen layout for now. But that's where that scaling comes in. In addition, we can adjust the volume of our system. That said, if there's an alarm, it runs off of a 100% volume of the display. Most of the noises that we have are adjusted by the master volume of the display. This would be a sub-volume adjustment. It works on certain displays, but not on all displays. If I hit the right arrow soft key, it takes me to our second page, terminal configuration. Right now we're locked in on our physical CANBUS 1 of our controller for UT display. However, in certain profiles we can push it to a different physical CANBUS. Also, you see change VT. If I click on that and I have more than one VT available on the CANBUS, right now I only have the one at my desk. If I click on here, you'll actually be able to see all the available VTs and pick between them. For now though, we'll just skip that part. And then lastly, we have time to wait for selected VT, and this goes hand in hand with the changing of VTs. So if I have, say, 2 VTs available to me, and I pick a preferred VT, for example, let's say an ag leader display is the one I want to display on right away. When I power up, if I don't see that ag leader display, I don't jump to the next display for a period of 10 seconds. If 10 seconds goes by, then I give up on the ag leader and I find the next available VT display. You can change that value depending on how patient you are and how long it takes a certain display to load up. The next icon over is our GPS configuration page. It has an icon letter C in the top right hand corner. If you click onto that, it takes you to your GPS configuration. The first page is for our input settings. To start out, we have our input signal type. Right now we're set up for RS-232, which is a serial connection to our controller reading the NEMA 0183 standard from a GPS receiver. If I click on here, you can select two different input types. The other two are CANBUS based messages, which are following two different standards. For example, NEMA 2000 is really common in the ag market. If I click on here, you can then have a listing of all available nav controllers on the ISOBus. Right now at my desk I have nothing set up, so it just has the stored last setting that I used, but here I can hit next and see all available nav controllers that are outputting NEMA 2000. If I change it to J1939, it would be the same process. J1939 is less common in the market or less standardized, but that said, for GPS output, the Starfire receiver would use this J1939 output, as well as a couple different displays on the market are set up to output J1939 GPS. And in our latest version of software, we can fully utilize that standard as well, saving wiring if you don't want to wire up a serial connection. But for today, we're going to use RS-232. When you have RS-232 selected, the other thing that can be adjusted is our baud rate. Our default in new software is 38,400. It can be adjustable to other baud rates. Most commonly is 38,400. Also 19,200 was common with older version software. Be aware that if you set the baud rate too low, you may not have enough bandwidth to support all the NEMA strings at the proper output rates. And if you have the baud rate set too high, you may have physical limitations due to noise. The higher the baud rate, the more susceptible you are to things like noise if you have a longer harness. On the next page is our error detection or our warning levels for GPS. And we have several different warning levels. We can either ignore all warnings regardless of correction level. We will not steer with a correction level of 1 or no correction. We need at least DGPS or higher. But we can adjust it where we can make it so it does minimal notifications while maintaining the auto steer system. So we could go from an RTK and drop off to WAS and we would still maintain auto steer. Or you can go to the most picky, where if we see any changes in signal, we deactivate the auto steer and provide a warning. So the default setting is 3, and if you can see here in the explanation below, in case of any signal changes, it'll provide you the information. It will not kick out the auto steer, but it'll give you a warning. In addition, we do have a timer if you want to add some kind of a filter to it. So if it flickers for half a second or a second, it doesn't create that issue. So this is a nice feature based off of a lot of customer requests. And then you can determine if there's a sound to go with the information or if it's muted and just a visual cue. On the next page, we have our output configuration. So if we have a valid GPS input, we can then convert that to one of two different standards, the NEMA 2000 standard or J1939. So a really nice feature of our system. For example, I can read the serial output from a brand X receiver, and then our system can convert it to NEMA 2000, which then can be utilized by a brand Y screen or a brand Y controller. And then in addition, with our GPS, we can read in and do terrain compensation either built into our controller and or external tilt or gyro sensors if we're using the LT controller. Or if we have a terrain compensated GPS receiver like a Starfire receiver, we can say we want to use the terrain comp out of the Starfire. This is an important setting to review. If you have a Starfire hooked up and you're using the terrain comp, we wouldn't want to have this on as well. Otherwise you would have double the effect of terrain compensation. Lastly, we do have an output pin, and in some wiring harnesses we can maintain output power to a receiver for a period of time after we see key off. Default is set to 0 hours, but you can set this up to 24 hours, and it'll continue to provide power from a battery pin into our controller, out this power pin for a period of time X, and then it'll power down. And this allows the receiver to stay powered up, especially if you have a receiver with a long convergence time. Good example, you park the tractor for a couple hours to do some work. You come back to the tractor, you keyed off the tractor, now the power on the receiver went down, power's back up, and maybe it's a correction source that takes 30 to 45 minutes to converge. Rather than do that, we could maintain the power for those 2 hours by doing this. The only trade-off, of course, is then you may have a situation where you're drawing on the battery for those 2 hours. The next icon over in the main menu is, it says GSM in a box here, icon letter D. This is for configuring a Reichhardt specific modem. In our case, we're going to go ahead and skip past this. It's not a very commonly used product currently for our market. However, it is something that can be used if you do have a Reichhardt modem connected. You'd have a green dot here. You could click connect, and you could actually configure and set up a connected Reichhardt RTK modem. The next icon over is our diagnostic menu. It looks like a picture of a stethoscope with the letters DIAG. In new software, you'll have an icon with an E in the corner. When you select that, you go to our diagnostic pages. The first page visible would be our inputs, terrain compensation diagnostics, GPS input diagnostics. If we have a clue modem connected, we have diagnostics. All our communication rates, some general system information, a second page of system information, our history of errors, and our software information and hardware information like serial number. So going back to the first page, we have our inputs, and if we have a directly wired angle sensor, we would see the reading right here. If we had 2 directly wired angle sensors configured, you'd see the raw readings of both angle sensors right here. The next value below is for our manual override. So if we had a direct wire pressure switch or pressure sensor or seat operator steering column sensor, something that we use to detect when the steering wheel is being turned, this will provide the current state of what we're seeing from that sensor. If it's a CANBUS steered machine, this stuff will always provide a generic state and will not change. Safety switch, if it's one's wired up directly to an input on our system, it will show this input and how it's configured. If it's a CANBUS steered machine, we typically utilize the functional safety of the machine, and this is usually disabled. But again, you can go in here and see the state of, for example, a seat switch or a field road switch, depending on how it's wired up right here. Below that, we have foot switch, which will show the input of a rocker or a foot switch that's wired to our system, show the state of that switch. If you're pressing in on the switch, it would say pressed, and that would update in real time in this menu. The next icon down is our in-work indication. That's a separate input to our system. Not overly common, especially in our market, but it can be used for another input, for example, for a implement height switch for detecting when we're in the field, not in the field, for implement guidance. The next page over is our terrain sensor. So right now here it'll show the yaw rate. If we're using an MC controller or a Reichhardt with a tilt sensor, Reichhardt LT controller with a tilt sensor, you'll see a roll angle. And then with our MC controller, we can also offer a pitch angle. I'm going to go ahead and change this at my desk to show how it updates. So if the machine is turning left or right, I can rotate the controller to the left or to the right. You can see the yaw rate change, turning left and turning right. And then I can also do a roll angle, leaning left, leaning right, and a pitch, leaning forward, leaning back. I'll place it back here on the floor of my office. See if it calms down a little bit. It seems like it's pretty level at my desk. Go to the next page. For our GPS input right now, we have RS-232 picked, and you can see right here we have RMC, GGA, and VTG. Our system prefers to use RMC and GGA. If the receiver is not capable of supporting RMC, we can also use VTG with GGA for steering. And if VTG is also present on the serial bus, it'll take RMC first unless it sees VTG first, and it'll lock in on that until you power cycle the system again. So if I go ahead and change some of these things, so I'm going to change the frequency from the receiver to 1 hertz, for example. You'll see right away 1 hertz. So If you see a lot of fluctuations here, you may have an issue with your wiring to your receiver, for example. So it's a really good tool for troubleshooting. And the other thing that's important to know is as long as the receiver's outputting, even if you're not outside, if you're in a building, these RMC GGA messages should still be transmitted by the receiver. So it's a really good tool for troubleshooting wiring to a receiver. Below that, you have your basic latitude, longitude, position information, which comes from the receiver directly. We have our heading, which is directly from the receiver again. The CANBUS heading is actually a calculated heading based on a combination of both heading, speed, and yaw. So I have a little bit of influence from the gyro. That's where that heading information is being affected slightly. Below that, we have number of satellites, our quality or our correction level. Right now it's DGPS. I'm going to change it, for example, to RTK right now, just to show you the difference in my simulator. Now I have an RTK fix. And again, that updates in real time. Just to show you here too, I'll go ahead and hit stop. It'll stop sending GPS. Give it a few seconds and you'll see the RMC goes to 0, lat long goes to 0. If I start up again, she'll fill back in here in about a second. RMC, GGA, lat long again. HDOP stands for horizontal delusion of precision, and that is related to overall quality. This is used for troubleshooting if you have some poor satellite spread, not super common in newer receivers with additional constellations. Reference age is the amount of time since the last bit of correction information we've received. Right now it's 3 seconds. That's pretty poor, but right now it's just a simulation at my desk. Reference ID and baseline would be related to your reference source, specific source, as well as how far are you from your reference source if it's an RTK base, for example. On the next page it says clue modem, and this would be diagnostics for an input, a clue modem input. We're going to go ahead and skip this section. Next page is communications, and this would be all our input settings. So our RS-232 port baud rate and our CAN buses, what's our bit rate for each CAN bus connected to our system. The really nice tool here is there's actually a message counter. Shows how many messages, and really what this is kind of a heartbeat or a pulse showing we have messages coming in on GPS with our RS-232. We are seeing messages on CAN 1. We're not connected to CAN 2 and there's nothing on it. So if you had an error related to CAN 2, for example, you can go here and see, well, I'm not seeing anything. There's no messages on CAN 2. It's probably a wiring issue, an open wire, or a lack of a termination. On the next page, we have our first page of system information. This is related to our voltages, power supply, as well as our output pins to different things like our sensors or a GPS receiver if our system's powering the receiver. Our system runs between 10 and 30 volts. If you start to see it drop below that, we can have some negative influences. So I've been on machines where we have a lower battery. We may have a relay voltage in that's high enough, but then our output voltage is too low, or we have a short somewhere. And this would help us really quickly examine why are we seeing an issue where we don't see our TAC sensors. Maybe we have no power going to the TAC sensors. That's where this could where this could help. Most commonly, though, it's an open wire to the sensor, but this would be another spot would be helpful for troubleshooting if you've verified all the wiring. Below, at the bottom of outputs, we have frequency, and this is just the frequency of our output signal if we're directly controlling a valve. And then below that, we have some controller specs, workload. If we have some real weird activity, perhaps we have some additional workload, a real high percentage. The microcontrollers processing frequency, but right now we're at 100 megahertz controller. We actually also have our LT controller, which would show up as a 40 megahertz, but that just shows you which controller you're running or what it's running at. And then below that we have our memory information. On page 2 it will show our vehicle code. It's the same vehicle code that you see in the teach menu that we talked about earlier. Our last exit code is an interesting, helpful bit of information, and what that provides is what kicked out our auto steer the last time it disengaged. So for example, if it said last exit code 1000, it actually would mean that the pressure sensor or flow switch, whatever's wired up for operator override is what kicked the auto steer. Typically that means someone turned the steering wheel. Below that we have operating hours, and it's just showing how many hours and for what distance has our auto steer been engaged. It's essentially a odometer. And then below that, this is time and date information, which is provided by the GPS receiver typically. And then lastly, and probably most importantly, are our active errors. So right now our system would have an active error of 108, and I could go into my error code list and it would show me exactly what is affecting our system. If that error is cleared, the next one in the queue would show up, and if there are no errors, it would say OK. We also have internal and ISO errors, and these are ones that we detect for internal troubleshooting at times. We'll put flags in our software for better troubleshooting. Next page is our error history, and if we have a valid date and time information available, we can actually stamp it as well. It'll tell you the error code as well as the number of times the error has been seen and when it was last seen. And you can page through and see all the different errors that have happened with this controller. On the next page we have our hardware software information, so it'll tell you your generation of controllers. So the one I'm running right now is the iBox MC controller, our version of software. I'm running a current test build, our serial number of the hardware, when the software was built. We're running a Reichhardt modem. It'll show some information about the Reichhardt modem, and depending on the receiver we're using, we can also get information off the receiver. The next icon over looks like a blue circle with an I in it. It has the letter F on the top right hand corner. If I click on that, it'll take me to our service partner information page. So right now we have our logo and our product logo, service partner, Reichhardt USA. This is our contact information, and if you have any questions, you can email our email. Some other OEM customers may have a different contact information, for example, different logo information. That's where this would show up. The next icon over looks like a calculator symbol with the letter G in the corner, and you guessed it, it is a working calculator. So if you don't have access to a calculator on your phone, you can go in and put some basic numerical entries. So for example, I can do 25 times 5, okay, and now I have 125, 625 times 5 over and over, and it does work. It does not do floating point or divide and do decimals, but it will get you some basic math if you need to do some quick multiplication or addition. The next icon over looks like a calculator, but it's a pin pad, and this is where a technician or an installer would put in a pin code for our system, and this allows additional access to additional menus. And there are different codes depending on the level of access. This is also the page you would use if we had a steering mode that needed to be entered in and opened up with our system. For example, if we decide to put sonic sensors on a combine, that's not common. We don't ship it with sonic mode, but we could put a code in and allow sonic mode to be accessed. As you can see, if I put in access code, you'll have additional icons available. I'm not going to show anything beyond this, but just showing that if you have access, also in letter A, you can see you have a bunch of different menus available, and there's different levels of access. And then there's a padlock icon, locks the system back up. And by default, a lot of these modes will lock themselves out either with a power cycle or over a given period of time.